एवरीवन, दिस इज़ मी निधि। हमने अपने पहले क्लास में पढ़ा कि कैसे करंट किसी भी सर्किट में पोटेंशियल डिफरेंस और रेजिस्टेंस पे डिपेंड करता है। हम इस क्लास में पढ़ेंगे कि कैसे हम रेजिस्टेंस का यूज़ किसी भी इलेक्ट्रिक सर्किट में करेंगे। हम अपने घर में डिफरेंट इलेक्ट्रिक अप्लायंसेस यूज़ करते हैं एंड इलेक्ट्रिक सर्किट ऑफ ईच इलेक्ट्रिक अप्लायंसेस रिक्वायर्ड स्पेसिफिक करंट. For this, we have to combine two or more resistance to get the desired quantity of current. The resistance can be combined in two ways. First, in series and second, in parallel. अगर हम चाहते हैं कि किसी भी इलेक्ट्रॉनिक सर्किट में रेजिस्टेंस ज़्यादा हो तो हम रेजिस्टेंस को सीरीज़ में जोड़ेंगे। जैसे रेजिस्टेंस R1 एंड R2 इज़ कनेक्टेड इन सीरीज़। और अगर हम रेजिस्टेंस को घटाना चाहते हैं तो हम उसे पैरेलल जोड़ेंगे। Here in figure A, the resistances are combined in series, and in figure B, the resistances are combined in parallel, R1 and R2 across two endpoint, that is AB. From this we get the definition of series combination and parallel combination. In series combination, when two or more resistances are connected end to end consecutively, they are said to be connected in series, while in parallel, when two resistances are connected between the same endpoint, which is given in figure B, that is the endpoint is A and B, they are said to be connected in parallel. जब भी हम रेजिस्टेंसेस को सीरीज में जोड़ते हैं तब उसका टोटल रेजिस्टेंस हम इंडिविजुअल रेजिस्टेंसेस को जोड़ कर निकालते हैं. एज फॉर एग्जांपल, कंसीडर रेजिस्टेंस R1 इज 5 ohm and resistance R2 is 4 ohm. Then when we calculate the total resistance across the circuit, then we find R equal to R1 plus R2. That will be equal to 5 plus 4 equal to 9 ohms. Before we are going to derive the formula for the resultant resistance of a number of resistances connected in series, 2 points should be keep in mind. जब भी हम रेजिस्टेंसेस को सीरीज में जोड़ते हैं तो पोटेंशियल डिफरेंस हर रेजिस्टेंस का अलग होगा, बट एट द एंड व्हेन वी कैलकुलेट द टोटल पोटेंशियल डिफरेंस देन इट इज़ द सम ऑफ the potential difference across each resistances. And the second point is that when a number of resistances are connected in series, then the same current flows through each resistance. This derivation can be better understood with the help of a figure. Now let us consider two resistances, resistance R1 and resistance R2 in a circuit. There is a battery connected through which potential difference is maintained. Let us consider that the voltage applied is V, and now we in the second point we study that the current in the circuit is same. Let us consider the current through the circuit is I. The potential difference across resistance R1 is V1 and across R2 is V2. Therefore, from first point we get V equal to V1 plus V2. Then V equal to R into I by Ohm's law. When we put its value in equation first, we get R into I equal to R1 into I plus R2 into I. Therefore, I into I equal to, when we take current as common, then R1 plus R2. We cancel out this, then R equal to R1 plus R2. In similar manner, we calculate the resultant resistance of three resistances connected in series and more than that of 3, 4 and so on. Now let us take a simple question. If four resistances each of value 1 ohm are connected in series, then what is the resultant resistance? Let us consider a figure where four resistances R1, R2, R3 and R4 are connected in series, each of 1 ohm. Now the resultant resistance is R equal to R1 plus R2 plus R3 plus R4. That will be equal to 4 times 1. That will be equal to 4 ohm. Now let us consider another question. A resistance of 6 ohm is connected in series with another resistance of 4 ohm. Now a battery of 20 volt is applied across the combination. The potential difference is 20 volt. The current flowing through the circuit is I. Let us consider it. As we know, when the resistances are combined in series, then the total resistance is the sum of both. That is R equal to R1 plus R2. Here R1 is 6 ohm and R2 is 4 ohm. That will be equal to 10 ohms. The potential difference V is given as 20 volt. To calculate I equal to V upon R. That will be equal to 20 upon 10 equal to 2 ampere. Our first question is, what is the current through the circuit? The current through the circuit is 2 ampere. Now we have to find the potential difference across the resistance 6 ohm. Then resistance is 6 ohm. Current I, that will be equal to 2 ampere. Then V equal to R into I from Ohm's law. Therefore, V equal to 6 into 2 equal to 12 volt. Therefore, voltage across or potential difference across 6 ohm resistance is 12 volt.